Okay, so now what we're going to do is take a look, a deeper look at the metric system to be more specific. And we're going to be looking now at prefixes that we use within the metric system. And these prefixes are used to change the size of a unit. Okay, and we'll use, let's just use the base unit for length in the SI system, which is meter. So starting point. So meter is m, lowercase m. This is the base unit for length. So there are prefixes that do the following. They can increase the size of the unit, or they can decrease the size of the unit. And there are lots of these within the metric system. We're going to limit ourselves to just a few that we're going to see more commonly. The first one here is called kilo. If I place the prefix kilo in front of the meter, what I end up with is a kilometer or a kilometer. And we abbreviate that as small k m, right? So kilo here has the abbreviation small k. And kilo, whenever you see kilo, that means 1,000 of that thing. If I put kilo in front of meter, that means I have 1,000 meters. So another way of saying this is that 1 kilometer equals 1,000 meters, which is the same as 10 to the 3 meters, right? You would see, kilometers being used to represent distances, or kilometers per hour, or speed on your speedometer in your car, for instance. That's a metric unit, a very common metric unit with length. So 1 kilometer is the same as 1,000 meters. The next unit that increases the size, the next prefix that increases the size of the unit is mega. So I have a mega meter. The mega has the abbreviation big M, uppercase M. If I put that in front of meter, I have big M, small m. And mega always means a million. So that means a megameter would mean 106 meter. So I can say 1 megameter equals a million meters. And that's the same, as you know now, as 10 to the 6 meter, right? So a megameter is a bigger unit, much bigger unit than a meter itself. Remember, these are prefixes, okay? So that means that they go in front of the base unit. And the last one we'll take a look at here that increases the size of the unit is giga. Okay, so giga meter, giga has the symbol big G. If I have a gigameter, big G, small m, giga means a billion, which is 1 and 9 zeros. So then we can say 1 gigameter is the same as billion meters, and we can express that in exponential notation. That's 10 to the 9 meters. Okay, there are others. We're going to limit our scope here to just these three. So kilo, mega, and giga. You need to know these, right? There's a reason why we're spending a lot of time going through this. You need to commit these to memory. So those are the prefixes that increase the size of the unit. So giga, mega, and kilo, big G, big M, small k, respectively. And you need to know their relationships as well. Now, the prefixes that decrease the size of the unit are going to be the following ones. So again, we're going to limit our scope to the most frequent, most common ones. The first one here is going to be centi. So if I have a centimeter, a centi is abbreviated small c, so that then would be cm. And then what we can say is a centimeter, 1 centimeter is 1/100th of a meter. So 0.01 meters, or 10 to the negative 2 meters. All right, so centi is a smaller unit. A centi of anything. A centigram is 1/100th of a gram. A centisecond is 1/100th of a second. The next one here is milli. So a millimeter, for instance. So milli here also has the abbreviation small m. Yeah, but now we're putting it in front of lowercase m, which means meter. So small m means millimeter. So a millimeter is 1/1000th or 0.001 of a meter, which is the same as 10 to the negative 3 meters, right? Millimeter, if you pick a meter, break it up into 1,000 equal pieces. That's what a millimeter is. A millisecond is 1/1000th of a second. The next one is micro. So micrometer. Micro has the symbol that looks a little unusual. It looks like a U with a tail at the front, right? And that's the symbol called mu. That's how you would refer to that. It means micro. So micrometer. I can say that 1 micrometer is 1/1,000,000 or 0.000001 meter, right? Which is the same as 10 to the negative 6 meters. So micrometer, sometimes it's called a micron. See, that's like when you think about having filters and stuff in your house, micron filters, they're able to filter out, really, really small particulate matter from the air, right? Similarly, when you have a fire or something and a lot of particulate matter goes into the air, well, some of those particles are really tiny, you breathe them in and they can clog up your airways and give you asthma and all that kind of stuff. Then you're getting into the scale, the particles that you can't see, but they're there. You're in the scale of the micro now, or micrometer. If you take this one step further, we have the last one, which is nano. So nanometer, nano has the symbol small n. So a nanometer then is even smaller than a micrometer. So 1 nanometer is now 1/1,000,000,000, 0.000000001 meters, which is the same as 10 to the negative 9 meters. Right, so these, again, we're going to limit ourselves to 154 units, or for prefixes, I'm sorry, that decrease the size of the units, centi, milli, micro, and nano, and how they relate to the base unit. Okay? And the thing about the metric system and the prefixes is once you use them, you know exactly what you mean. Okay, so a nanometer, 1/1,000,000,000th of a meter. A nanogram, 1/1,000,000,000th of a gram. A nanosecond, 1/1,000,000,000th of a second. It means the same thing wherever you use it, and always means these relationships. Okay, so you need to know these. There are 7 of them, right? Going from giga, mega, kilo, centimilli, micro, nano. You need to know these, and you need to know not just their prefixes, but what they mean, their abbreviation, and then how they change the size of the unit. Okay, I know that most of us didn't grow up with the metric system, but this is what we use in science. Okay, and that's what we use when we communicate data and observations and results and all that stuff. We're going to use the metric system. That's the agreed upon system that's used. So now that we have a basic idea of these metric prefixes, let's take a look at how we can convert between them. We're not going to spend a whole lot of time on this. I'm just going to show you one technique called dimensional analysis that is very useful when converting between different units. So dimensional analysis. This is sometimes called unit conversion because that's all that we're doing. Or sometimes a factor label method. This is grounded, it's based upon what are known as equalities. Okay, and we wrote several equalities already. So for example, let's take a look at the kilometer up here. So we said that one, as an example, 1 kilometer is equal to 1,000 meters. Okay, that is an equality. Something being equal to something else, that is what an equality is. It's really not that difficult. Now, once you have an equality, we can come up with what are known as conversion factors. And what a conversion factor is simply taking one side of the equality, putting it over the other side. equality. So 1 kilometer over 1,000 meters. To get the other conversion factor, we just flip it. So then we have 1,000 meters over 1 kilometer. And these are what is going to be useful for us as we convert from one unit to another unit, whether it is within the metric system, like these prefixes, or whether it's going from one system to another system, it didn't matter. You can use the same technique of dimensional analysis to convert any unit to any other unit, as long as you have this thing here, which is your equality. Okay, let's take a look at an example. Let's say you want to convert 2.56 kilometers to meters. Okay, and this first one here, you may be able to do this in your head, one-step process, but I want to show you how we use the dimensional analysis to set this up. You want to organize your information. First of all, okay, what are you given? And then what do you mean? Okay, so here we're given kilometers, 2.56 kilometers. We need to convert that to meters, right? So what are we going to use? Those are the three questions that you're going to ask yourself. What are you given? What do you need? And what are you going to use to get there? Well, we need a relationship that connects kilometers and meters. Well, we just talked about this. We know that 1 kilometer equals 1,000 meters. Okay, and then we have our two conversion factors that we could use. 1 km over 1,000 m, or 1,000 m over 1 kilometer. So as I'm writing these out, hopefully what you're also hearing is that I'm not just putting the numbers 1 over 1,000 or 1,000 over 1. I'm also keeping track of my units, right? Because that will actually help you figure out how you do this. If I'm going to set this up now, you always start with what's given, 2.56 kilometers in this case. You'll put that over 1, then I'm going to multiply it by one of these three conversion factors. Which one am I going to use? Well, my units are going to dictate to me. If I want to end up with meters, I'm going to select the conversion factor that has the meters on top. So I'm going to take the one here on the right, stick it in, 1,000 meters over 1 kilometer. Guess what? My kilometer units I can cancel out because they are on opposite sides of the dividing line. Okay, so they can cancel out. I end up with meters as my only unit. That makes sense because that's what I'm trying to find. Then I just multiply 2.56 by 1,000, so I get 2,560 meters as my unit. You could have done that in your head. I understand that. But this is how you set it up in a way that makes sense, that allows you to double check your answer or your calculation as you're doing it. And the check here is the units, right? If you find that your units don't cancel out, chances are you set up your calculation incorrectly. You maybe need to flip your conversion factor, or maybe your conversion factor is just wrong because you're starting off with a wrong equality. Okay, let's take this into another step. Let's say now I want to convert, let's say 0 point, actually, let's do a one. Let's convert 6.25 times 10 to the negative 3 centimeters to kilometers. Okay, so we have what we're given here. So we're given 6.25 times 10 to the negative 3 centimeters. And then what I need to get to is kilometers. So keep in mind now, what I'm doing here is I'm going from a small unit, centimeters, to a much larger unit, kilometers. So just before I do any calculation, I can predict the relative size of my answer. Right? If I'm going from a small unit to a big unit, my answer here should be really, really, really small. Okay, just like, or in the opposite case, when we did our first example, we went from a large unit, kilometers, to a small unit, so we could predict that the answer should be big. It should at least be larger than what we started with. And it was, right? 2,560 is greater than 2.56. Well, here now we're going from a small unit to a much bigger unit, so the answer should be really small. So what am I going to use to get from centimeters to kilometers? Well, you may not know the relationship between centi and kilo, right? But we should know the relationship between centi and then the meter, and then the relationship between meter and the kilometer, right? Because we related all of these metric prefixes to the base unit, which was the meter for every single one of these cases. So even though I may not be able to go from centi to kilo in one step, what I should be able to do is to go from centimeter to meter first, then meter to kilometers, right? So I've broken it into a couple bite-sized pieces, and now I can establish my equalities for each of these steps. So from centi to meter, if I go back and check my notes here, says that 1 centimeter is 0.01 meters, so I can write that as an equality. So 1 cm equals 0.01 meters. And then we're going from meters to kilometers. We know that 1 kilometer equals 1,000 meters. Okay, so now what I can do is I have two equalities, which means I'm going to have to select two conversion factors from each of those. Let's go ahead and set this up. So I always start with what's given. So 6.25 times 10 to the minus 3 centimeters. Put that over 1. And then my first conversion is to go from centimeters to meters. I'm going to take this and stick it in here. I'm going to put it in such a way that I want to end up with meters as my intermediate unit. That should then go on top, right? The thing with meters should go on top. So 0.01 meters on top. That's for every centimeter on the bottom. Centimeter goes away. Cancels out. I'm at meters, my midway point. Next step, go from meters to kilometers. I want to end up with kilometers. So guess what? The kilometer side is going to go on top. So 1 km. Then I have my 1,000. The other one goes on the bottom, 1,000 meters. Guess what? Meters cancel out. Okay, so I end up with kilometers as my unit. Units make sense. That tells me my setup is perfect. Then I would just need to evaluate this. So multiply out 6.25 times 10 to the minus 3 times 0.01, and divided by 1,000. And that's going to give me my answer here. So let's evaluate that. If I multiply that by 0.01, that gives me, what is that? 6.25 times 10 to the negative 5. And then if I divide that by 10 to the 3, so that's going to give me 6.25 minus 10 to the negative 8 kilometers. That was my final answer, right? And you can double check this. I'm not going to do the step by step for you at this point. You want to make sure that you're good, you're proficient with using a calculator. So my final answer here, 6.25 times 10 to the negative 8 kilometers, right? That is a really small value, right? Much smaller than 10 to the negative 3, right? Specifically, it's 100,000 times smaller than my original conversion. So the answer makes sense, units make sense. That's how dimensional analysis works. You can use it whether you're going within the metric system or whether you're going between a metric system and the imperial system or the British system. As long as you know what that equality is, you can use this for any conversion, any unit conversion that you need to do. All right, we'll do one more example involving conversion factors and dimensional analysis. So going back to the very first thing we talked about, which was the confusion between kilograms and pounds for this particular plane. We'll just kind of show you here what we can, right? So let's say we wanted to convert, take a value of like 55 kilograms, 55.0 kilograms per pounds. Okay, so here now we have again what we're given 55 kilograms, and then what we need to convert that to pounds. So what are we going to use? We need a relationship between kilograms and pounds. Now, I don't expect you to know all of the relationships between a metric system and some other system, like the imperial system or the British system. In most cases, you can look that up, or you'll be given it on a quiz or an exam or something. So here we need to know that relationship, right, between kilograms and pounds. You can look it up in your textbooks, or for example, in the appendix. There's all sorts of relationships that you can see. I'm just going to reference it here from your again textbook, Appendix B and Appendix C, I believe. Has some of the relationships between the metric and the British system, as well as some of the prefixes we talked about before. So looking it up, we can see that one kilogram is the same as 2.20. Fixing up inequality. I'm given here, I'm starting off with 55.0 kilograms. Put that over 1. I'm going to use my equality as a conversion factor. If I want to end up with pounds as my unit, that's the side that I'm going to put on top. So 2.20 pounds for every 1 kilogram. Kilogram goes away. I end up multiplying now 55.0 by the 2.20. Okay, and that's going to give me 121 pounds. Right, so you can see when I do this conversion that when I compare my kilograms to pounds, right? Kilograms are roughly, well, pounds are usually just over twice as much in terms of actual value or numbers here when we do the conversion as to what we have on the kilogram side. Another way of saying that is a pound is just under half of a kilogram. And if you go back to our original problem that we had, right, the plane here needed 20,000 kilograms of fuel. They only put on 20,000 pounds of fuel, right? So that's why it was roughly about half of what the amount that they needed. If you convert that, you can see it's just under 10,000 kilograms, and that's why they ran out of fuel. So the point here is we can use this dimensional analysis, this unit conversion, the equalities and the conversion factor to convert between any two units. They don't have to be within the metric system. They can be between the metric system and a different system, as long as we know what that relationship is, or what the equality is that relates the two units that we're looking at.